Today, we'll find that division of complex numbers aren't going to be quite what we expect them to be. But that doesn't mean that they are difficult. Let's look at a fraction involving a complex number. 5 divided by I. Looking at this, we would assume that there's nothing that can be done here. However, if you replace I with its square root counterpart, 5 divided by the square root of -1, you can clearly see what's wrong. Any expression with the radical in the denominator is not considered simplified. What we can do to simplify this is to multiply the numerator and denominator both by I. 5I divided by I squared. Since the denominator becomes -1, this simplifies to 5I divided by -1, which equals -5I. As you can see, sometimes you need to employ unexpected methods to simplify an expression. You just witnessed one such technique. If a rational expression seems difficult, you can often multiply the numerator and denominator of the expression by some term. This method works by virtue of the inverse property of multiplication, which states that anything divided by itself equals 1. In our example, we had 5 divided by I, which was useless to us, but we also know that I divided by I equals 1. So by multiplying this to our expression, we obtained something that was workable. This is often a method that's sometimes hard to identify when it's appropriate to use, but it's a great tool nonetheless. One other method that's used often is multiplying and dividing by the conjugate of the denominator or numerator of the expression. You'll see this done in some of the examples that we'll look at now. Number 1. 10 divided by 3i. Here we have a single-term rational expression. Multiplying the expression by I divided by I will give us 10I divided by 3i squared. Simplifying this leads us to 10I divided by -3, which we can simplify as -10 over 3I. This would be the correct way to write it because remember, we want A plus BI. And this -10 over 3 is considered the B. Number 2. 4i divided by 2 minus 5i. Now we have a binomial in the denominator. Let's multiply this expression by the conjugate of the denominator. 4i times 2i plus 5i divided by 2 minus 5i times 2 plus 5i. The denominator is a sum-difference product, which simplifies easily. And then we can use the distribution on the numerator, giving us 8i plus 20i squared divided by 4 minus 25i squared. This becomes 8i minus 20 divided by 4 plus 25, which equals -20 plus 8i divided by 29. We have one last thing to do. We must put this in standard form. -20 over 29 plus 8 over 29i. This is your A term, and this is your B term. Number 3. 4 minus 3i divided by 5i. This expression doesn't have a binomial in the denominator, so we don't need to multiply and divide by a conjugate. But we still need to multiply and divide by I to make this workable. 4i minus 3i squared divided by 5i squared. We can then simplify. 4i plus 3 divided by -5, which equals 3 plus 4i divided by -5, which equals -3 over 5 minus 4 over 5i. Notice we had to get the numerator into standard form first before we could put the rest of the fraction into standard form. Number 4. 4 minus 3i divided by 9 plus 7i. This time around, we have a binomial in both the numerator and denominator. Let's multiply this expression by the conjugate of the denominator. 4 minus 3i times 9 minus 7i divided by 9 plus 7i times 9 minus 7i. Just with the last time, the denominator is a special product, but we'll have to use FOIL on the numerator. 36 minus 28i minus 27i plus 21i squared. divided by 81 minus 49i squared. Now we just simplify. 36 minus 55i minus 21 divided by 81 plus 49, which equals 15 minus 55i divided by 130. We're not done yet. We can simplify one step further. Even though a complex number is made up of a real part and an imaginary part, we can still factor a GCF from both parts if it divides the denominator. In our case, we can factor out a 5. 5 times 3 minus 11i divided by 130, which equals 3 minus 11i divided by 26. We can finally put this into standard form. 3 over 26 minus 11 over 26i. Division of complex numbers was somewhat different from what you may be used to. However, this type of division becomes exceedingly common the further you go into mathematics. As a matter of fact, you start to see a lot of it in trigonometry. We have one more lesson to go through for this chapter. We're going to talk about the powers of I.